Imagine climbing to the summit of Mount Everest, though confined to a wheelchair. Standing in the Nairobi desert in the year 3185. Holding the entire Library of Congress in the palm of your hand. If these ideas seem impossible, think what early settlers of our country might have said to exploring the woods with flashlights, or flying over the Continental Divide in an airplane. Who living then would have believed it possible to walk on the moon? Argonne National Laboratory supports a new community of scientists and researchers who are breaking barriers to even more revolutionary advancements. The barriers? Time and distance. The barrier-shattering prototype, iWay.
All right, you want to read it back to me?
iWay, which stands for Information Wide Area Year, began as an idea to push the limits of high-speed distributed computing. Using telecommunication carriers to connect remote supercomputers, iWay demonstrated a nationwide collaborative environment. Virtual reality interfaces, like the Cave, meant scientists and researchers could literally immerse themselves in data.
What we were proposing to them is to take a leap forward about 10 years. Seeing where things break and where they hold up, that's of critical importance and value to the carrier community today.
iWay won the support of independent telecommunication carriers and some 30 different research and academic institutions. Overcoming time and distance, iWay debuted at Supercomputing 95 in San Diego, California.
What they're seeing is networks at speeds that they've never seen before and probably will never see again for another few years.
We did definitely push the envelope. There's a whole community of people now who have a different way of thinking about how to do supercomputing, how to do visualization, and have been part of an experience that will guide or influence how they think about science in the next few years.
One problem was finding a way to let many different kinds of supercomputers talk to each other. Led by Argonne, iWay teams developed iPop machines, point-of-presence computers, installed as uniformly configured gateways to the supercomputers.
We're going to go with Argonne.
The use of these iPop machines meant that we could basically develop a single set of software that would run at all the sites.
iWay teams wrote iSoft, management and parallel programming software, which created a necessary standard software operating environment.
We had a small team of people at Argonne National Lab who defined the basic architecture.
iWay enabled new ways to conduct research. Virtual reality interfaces allowed scientists to interact, come face-to-face with their data.
This year we're introducing two more virtual reality projection-based devices. The Immersidesk, which is a single-user drafting table format device, and the NII Wall, which is a very large screen projection display which can be in stereo or mono mode.
One of the reasons, of course, we've been working on the virtual reality is because it's an excellent test for this kind of technology. We need the supercomputers to give us the realism in the simulations, and we also need the high-speed networks to give us the feel of telepresence, of being somewhere else.
From inside the cave, this simulation shows gas collapsing to form stars. Supercomputers and high-speed virtual reality environments like this one are critical to further develop interpretive models of underlying physics. In this tornado simulation, the Powerwall enables scientific discovery by locating areas within the storm that have differing flow characteristics. The immersive capabilities supported by virtual environments permit engineers to go inside this virtual boiler and understand flue gas flows.
We had been looking at issues of how to pull high-performance networking and high-performance computing together. So when the iWay project came along, it was somewhat of a natural fitting into an experiment. We really merged a lot of communities. So we brought together the advanced networking community, we brought together the parallel computing community, the applications community, and the virtual reality community. And we also explored how to manage this large endeavor. I mean, we had over 300 people involved in making the iWay work.
The first distributed supercomputer network of its kind, iWay presented many unknowns to network specialists. Managing its fragile and complex character from the Network Operations Center meant solving round-the-clock problems no one had ever seen before.
There was nobody coming down here saying, are you doing your job? I think it was that we just all wanted it to work.
In another significant accomplishment, Argonne, working with IBM, staged the first live press conference ever to be run over ATM links. Using a digital video server, the press conference was held between scientists and engineers in San Diego and news reporters in New York City. iWay's success is just the beginning of understanding the technology it represents. Perhaps for the first time, we are witnessing capabilities and resources accelerated beyond our ideas. Perhaps for the first time, we will find ourselves only limited by what we can imagine.
I think that there's a lot of national support for continuing something like the iWay to provide a test bed where people can actually understand how to use this capability.
There's a great team here, both from San Diego, from Argonne.
We've had a lot of student volunteers. We had maybe 8, 10 rooms that we had to have workstations and cameras in every day.
We've learnt that a lot of the things we thought were hard were even harder than we thought. We learnt that other things that we thought were hard were perhaps not as difficult as we might have imagined. And we also learnt about problems that we hadn't even thought of.
We figured out that we were probably trying things that was about 3 years before it'll be generally possible to do it. If we tried to do this last year, nothing would work. If we do it 3 years from now, it would be uninteresting.
What iWay has done on multiple levels is touched various communities that will be impacted by the research, by the networking experience, and by the impact of those two combined on the way we do business, on the way we educate, on the way we basically communicate.
New use, it's exciting stuff.
I got outside today for an hour to go buy earrings for my daughter. That was it.
At this point, we're calling it a huge success, and we learned a lot.
At this point, we had never had to pull all of our ATM customers into a single facility. It was a challenge.
What we actually did accomplish was much more than we ever expected that we'd be able to do.
I don't know where the other gun is. Live action video. We must de-stress these people every now and then.
So how was the show, Bill?
Yeah, the show was great.